Hi, everybody. We are now at the midpoint of our summer session on critical reasoning, and I decided to pull up a slide of the middle portion of our Moodle site to indicate where we are and to point out some things that I've added for this week's material. In particular, these YouTube videos here. These are videos that are all about creationism and fallacies that are made by people who support creationism. Anyway, these videos are really entertaining and very useful to learn from when it comes to learning about some of the common ways in which we fall into the trap of faulty reasoning, which is the topic of today's of this week's discussion. What I'm going to do is go through our lecture notes as I've been doing for the past previous lectures, and I'm going to present the material in a slightly different way. What I'm going to do is first give you the illustration of the faulty reasoning, and then explain how the faulty reasoning is committed. In other words, I'm going to give you an example of faulty reasoning, and then go back to the example to explain why that reasoning is bad. You'll also notice that underneath the lecture notes is what's called the Book of Bad Arguments. This is a link to a really wonderful website which has a book of bad arguments, which is beautifully illustrated. It almost looks like a children's book. But it goes through the same material that I go through in my lecture notes. So I strongly encourage you to take a look at the Book of Bad Arguments to reinforce what you learn in the lectures. Also, I encourage you to look at these video presentations, these YouTube videos of people making or committing these fallacies. I might even have a forum post project for this coming week on some of these fallacies that are reported in or recorded in the YouTube videos. So be sure to take a look at these. You can do it before going through my lecture notes or after. I realized that I learned a lot more by going through these videos at least 2 or 3 times. So take your time with them, and sometimes the fallacies are so silly that they're quite entertaining. So it probably is going to be, this is actually my favorite section of the course. I'm hoping that you'll find that a lot of the things that you learn in this segment of our course is applicable in your everyday evaluation of what people say. Maybe you can even catch yourself committing these fallacies. Whatever the case may be in your application of what you learn here, I'm sure a lot of it will resonate. Okay, so I'm at the very beginning table of contents of this week's lecture on faulty reasoning. Another term for that is fallacies. And this lecture, as you'll see, is basically about informal fallacies, and I'm going to explain the difference between formal versus informal reasoning in a minute. But what you see here are all instances of informal fallacies, and this is one of the very few times I'm going to ask you to memorize terms, but I think you'll appreciate knowing the terms for the fallacies, because if you know them by their terms, it's a lot easier to identify when you actually hear somebody committing it, when you read a text and you see somebody committing it in writing. So I'm on the top of page 2 of our lecture notes, and its first entry is on the difference between formal and informal fallacies. The main difference between formal and informal fallacies has to do with whether or not the reasoning can be represented in like an algebraic formula. So here's what I mean by that. I just shrank our lecture note and put it to the side to give me some space to give you a demonstration of the difference between formal as opposed to informal reasoning. Formal reasoning has to do with, as I said, whether or not you can represent the reasoning in terms of a formula. So here's an example. If so-and-so, then such and such. The such and such will be the squiggle. The so-and-so will be the straight line. Now, the way to think about that is if you drive a car, then you know how to drive a vehicle. Okay? Now, let's then say that it's true that you do know how to drive a car. That's the second premise. I'm just going to abbreviate that by saying car, but that means that you do know how to drive a car. It's going to follow from this premise and this premise that you know how to drive a vehicle. Now, what makes this an instance of formal reasoning is that it doesn't matter what you put in for this and for this. As long as it conforms to precisely this way of reasoning, or this pattern or structure of reasoning, which, if you recall from the previous assignment, is called modus ponens. Doesn't matter what you put in here and here, as long as there's an exact match with the if part of the statement and the other premise, and the conclusion is the then part of the if-then sentence, then it's always going to be valid. And what makes this formal, again, is that you can represent the reasoning in terms of this kind of exact, precise formalization. With informal reasoning, you just can't do that. And in fact, whereas deductive reasoning is formal reasoning, inductive reasoning is what you call informal reasoning. And here's an example of why inductive reasoning is not formalizable the way that deductive reasoning is. The illustration that I give in the lecture notes is about making a generalization on the basis of a certain sample set. So let's say you see a certain dog, and that dog 1 barks. Another dog, D2, also barks. And then let's say that you do that for, I don't know, 7 or 8 more dogs. It barks. Well, with a sufficient sample set, how many do we have so far? We have 7 or 8. You're going to be more confident in drawing the conclusion that all dogs bark. But notice that there is no clear cutoff point about exactly what's going to make this an inductively strong conclusion. Surely, if you look at more dogs, say, if you increase your sample set of dogs to 50, that's going to be stronger than the current 8 for this argument. If you increase the set to 150, that's still going to be even stronger than the sample set of 50. 1,150 is going to be even yet stronger. But the point is this: I can't, or nobody can, declare precisely at one point the number of dogs that you have in your sample set is going to be sufficient for making a conclusion like this inductively well supported. So that's mainly the difference between formal reasoning and informal reasoning, and what we're going to be looking at is fallacies in this area, in informal reasoning. And you'll find that these fallacies are pretty familiar if you think about how people reason, or rather how people fail to reason when we go through the fallacies. Now, the book makes a distinction between two classes of informal fallacies. The ones that are based on irrelevant premises, and another set of informal fallacies that are based on unacceptable premises. I'm not going to worry too much about maintaining this distinction. They're all fallacies, and I want you to know them whether or not they belong to this class or the other class. So you can forget about knowing which fallacies belong where. I'm going to just begin with what's called the genetic fallacy, and this is a fallacy that, contrary to what the term might suggest, it doesn't have anything to do with your genes per se. Rather, it has to do with where information comes from. So, as I said, what I'm going to do is I'm going to go through the examples first, and then, by looking at the examples, I'm going to talk about the definition and explain how these examples fit that definition of the fallacy. So, okay, let's start with this one. Here's a claim that you often hear by strong religious believers of a certain stripe. Not all religious believers believe this, but this is something that some people will say. And it's this: the world was created in 6 days because the Bible says so. And the support for the claim that the world was created in 6 days is from the authority of the Bible. So let's look at another illustration. Gay marriage is illegal because the Pope disapproves of it. So the claim, gay marriage is illegal, or that gay marriage is bad, is supported by reference to what the Pope approves of. Okay, so I'm just going to look at these two examples and explain why reasoning like this is not a legitimate or a good way of reasoning. It's because the support for these claims goes to where that claim is supposed to be supported. And here, the support is supposed to be coming from, in other words, the source of it is supposed to be the Pope. The source of this claim is supposed to be the Bible. And generally what's going on with the genetic fallacy is that when something is claimed to be true or false solely because of its origin. The reason why this is a fallacy is because it doesn't defend a claim on the basis of its merit or on independent evidence. It defends the claim simply by citing the source that supports it or doesn't support it. And that's not a good way of gathering your evidence. Now, with every fallacy, informal fallacy that is, there is what's called a caveat. This is the Latin term for warning. And I put these in here. I don't think the textbook does this very well, but I put these in here to demonstrate that sometimes appealing to origin is a legitimate way of reasoning. In other words, it's not fallacious when you do that. So, for example, when you cite an expert in his or her area of expertise to demonstrate that a certain claim should be supported or is true, in a way, you are going to the origin, but it's not a fallacy in this case because we expect experts to know what the facts are. Whereas we can't necessarily say that the Bible or the Pope is always going to be the authority for scientific facts or for every kind of moral fact. And I know that that's controversial among religious believers, but when you reason, you want to make your claims as universally acceptable as possible, and these are not ways of doing that. So again, I go to the caveat here, which is that sometimes you can cite a source to support a claim. The difference between legitimately using an expert, sorry, that's a typo, an expert, and committing the genetic fallacy comes down to the way the source is used. When you commit the genetic fallacy, you simply assume that there's nothing more to backing up the conclusion or to backing up the claim than just citing the source. On the other hand, when you use experts, you admit that experts themselves may be wrong, and it's more of an attitude of openness when you appeal to an expert to support a claim, as opposed to merely saying that the source that you cite is going to end all discussion immediately. This gets to an important point about degrees of belief, which we discussed last week. As I said, one of the principles of good critical reasoning is that you proportion your belief according to the evidence, which is a fancy way of saying you believe as strongly as you have evidence to back it up. And depending on how much evidence there is, you believe something very strongly or kind of, not so strongly, or you just suspend your belief altogether because you really have no idea one way or the other. The point is that when we're talking about beliefs, we really have to understand that it comes in degrees of strength, that you really believe something strongly or not so strongly. It's almost impossible to believe everything that we have in our heads with absolute certainty. The responsible thing to do is to be as informed as possible and to use reliable experts in their field of expertise to help us get through technical things that we wouldn't know about. For example, I rely on my dentist to tell me how to take care of my teeth. I can't do all the dental research on my own to know exactly what to do and how to take care of certain kinds of problems, or whether, for example, my daughter needs braces or something like that. That's something that a dentist would know, and we appeal to experts to do that. The point is, you try to be as certain as possible, but you can't always reach absolute certainty, and that's okay. The point is that you're always striving to get greater clarity, get greater evidence for or against a belief. Okay, so I'm now on top of page 3 of our lecture notes, and on this page of our lecture notes, there are two fallacies, the fallacy of composition and the fallacy of division, and they're actually flip sides of the same coin. So the fallacy of composition, let me just give you an example, and you can see why there's something questionable about this way of reasoning. So let's just go with this first example. The reasoning goes like this: the molecules in the ocean are smaller than a pin. So the whole ocean is smaller than a pin. Basically, you're saying that what is true of a part of an entire whole also applies to the whole. And even though molecules, individual water molecules, are really small, they're smaller than a pin, surely it doesn't follow that an entire ocean, which is basically a huge set of molecules of water, that the whole thing, that the ocean is smaller than a pin. I'm going to go now to the fallacy of division to compare it with the fallacy of composition to show you that they're really flip sides of the same coin. In this example, when I say the cake that Jack baked is very sweet, so each ingredient in Jack's cake must also be sweet. That's not necessarily true, and if you've done any baking, I don't do much baking, but if you have done much baking, you'll know that flour just by itself isn't sweet at all. Neither is the baking soda or the salt that you would put in to bake a cake. So some of the ingredients surely might be sweet, and that would be sugar that goes into baking a cake. But just because you put in a lot of sugar to make the cake sweet doesn't mean that each ingredient or all the other ingredients in the cake are also sweet. So here's what's going on. With the fallacy of division, what you're saying is that what applies to the whole also applies to each of the parts. Excuse my handwriting. It's really hard, actually, to write really well with one of these iPad styluses, so I'm going to try my best. On the other hand, the fallacy of composition is making a mistake in the opposite direction. It starts off with a claim about one of the parts, and then it makes an inference, an erroneous or faulty inference, that the whole also has that feature. I'm just going to pause right here to review something from the assignment from last week. The question was about whether it's ever appropriate to say that an entire argument, where an argument is premises and a conclusion, sometimes it's 3 or 4 premises, sometimes it's just one premise. I'm just going to go with this very generic representation of an argument, that whole thing, the premises leading to the conclusion. And I'm not going to worry about whether it's an inductive or deductive argument, because this point applies to both kinds of arguments. The question was whether or not it's ever appropriate to say that this whole thing is true or false. And the answer is, it's not. Truth and falsity are properties of parts of arguments, which are the individual statements, the premises and the conclusion. But these apply only to the individual statements that make up an argument. They don't apply to the argument as a whole. And if you were to do that, if you were to say that an argument is true, you would be committing the fallacy of composition. So saying that an argument is true commits the fallacy of composition. On the other hand, if you were to say that this is valid, or that this is valid, or I don't know, if you were to say that this premise is sound, you would be making the opposite kind of fallacy. You would be committing the fallacy of division. That's because soundness and validity are really properties of the whole thing. They're not properties of the parts. So I'm going to very quickly go over the definition of the fallacy of composition. The definition of this fallacy is that when you erroneously assume that just because the parts of something have a certain feature, that the whole thing also has that feature. That's not always true. Now let's go down to the fallacy of division. As I said, that's the flip side of the fallacy of composition. The definition of that is where you assume that just because a thing, a whole, has a certain feature, that the parts that make up the whole also have that very same feature. And I demonstrated these fallacies when we incorrectly use the term true or false when describing an entire argument, or when we use the words like cogent or valid when we're talking about the individual premises or conclusion that make up an argument. Now, as I said before, every fallacy, it's really a way, fallacies are mistakes in reasoning given the way in which you're mistakenly reasoning. And because it's informal reasoning, there are no hard and fast rules. It's not like modus ponens where you can fill in whatever follows the if part and whatever follows the then part, where you're going to get that valid result no matter what. With informal reasoning, you're always going to have exceptions or caveats, which, as I said before, is Latin for warning, and I basically put this in here. I'm saying, hey, this is a warning. I don't want you to think that this is always going to be a fallacious way of reasoning, or that the fallacy of composition is always a fallacious way of reasoning. Sometimes it is totally legitimate to say that something that is a feature of a part is also equally a feature of the whole. For example, if you're talking about a complex machine, if a part inside of that complex machine is broken, it's going to be quite likely that the whole machine is not going to work well, that it's broken too. So in that case, going from part to whole makes sense. Likewise, sometimes it makes total sense to go from whole to part. So for example, if an entire chorus of singers is singing perfectly harmoniously with each other, then it's reasonable to say that each singer is singing in tune with the other singers. So to say that the whole sounds musical, you can infer that each musician is also musical. So I'm now on top of page 4 of our lecture notes, and on this page we have the fallacies of appeal to the person and equivocation. I would say that of all the fallacies that you hear on a more regular basis, appeal to the person is among the most common. The Latin term for it is ad hominem, and I'm not going to ask you to distinguish between abusive and circumstantial and regular ad hominem. They all share a common feature, and I'm not going to be too picky about you're making sub-distinctions within the ad hominem fallacy. But basically, an argument commits this fallacy when you discredit a claim by discrediting the author. So in a way, this is a little bit like the genetic fallacy, because you are going to a certain source, saying that the source should be believed or not believed, and that's the reason why you are discrediting the claim. And the reason why that's fallacious is because you're not evaluating the claim on its own merits, but you are making the claim less credible, according to you, by citing where that claim comes from. So for example, let's just take a look at this example here. Suppose somebody says, Congressman X says that we have to increase state taxes to fund public education. But this is preposterous. Of course, Congressman X would say that because he has 6 children who are all in public schools. The way that this commits the fallacy is by saying that this proposal to increase state taxes to fund public education is a bad proposal because Congressman X has something to gain by instituting this policy. Maybe he does have something to gain, but for all that, it doesn't mean that this is a bad policy. It could actually be a very good policy because many people might be able to benefit from it. And we see a lot of instances of this fallacy. Let me just give you another one. Let's say these are 2 individuals who are arguing. A says, don't smoke. you shouldn't smoke because it's unhealthy. And then B says, well, why should I stop? Because, hey, you also smoke. Well, even though A might also be a smoker, A's advice to B might be a very good piece of advice. In fact, whether or not A is a smoker doesn't have anything to do with the fact that smoking is harmful. So just because a smoker says that smoking is harmful doesn't make the message any less true. And the one who's committing the fallacy in this little discussion is B. B is the one who is saying, hey, why should I take that seriously? You're being a hypocrite. When in fact, if B is being thoughtful, B should recognize that smoking is harmful and that that's true, even though that message might be coming from a smoker. Okay, so here's an exception. Again, sometimes, as I said, there's going to be exceptions to the way that the reasoning is conducted that seems fallacious in one context, but then in another context, it's perfectly fine. So sometimes the very credibility of a person has to be taken into account when you evaluate the truth of what they say. So just because someone who might appear not credible to say something doesn't necessarily mean that what they say is untrue. However, in the context of being a witness in a trial, if you're in a courtroom and a witness was discovered to be a frequent liar, then instead of saying that everything that the witness has said is false, what you're going to have to do is just simply say, you can't take what they say as being true. That's not the same thing as saying that it's false. You're just going to have to say you don't know. So the point is, the ad hominem fallacy is committed when you discredit a claim by attacking the author of the claim, either the circumstances of the author or the integrity of the author or the character of the author, or what the author does in the case of being a smoker. But sometimes the circumstances of the author is going to be highly relevant when you evaluate what they have to say, or it's going to be highly relevant to how much you put belief or suspend belief in what they have to say. The fallacy of equivocation is a lot less common than the ad hominem fallacy that we just went over. Nonetheless, you do sometimes hear people commit this fallacy in speech or when they're having a heated discussion. The examples that I have here are pretty crude. I wouldn't think that people commit these kinds of fallacies because they just sound so silly. But just to illustrate what's going on, here is a very, here's a good word, egregious. Meaning outrageous illustration of the fallacy of equivocation. So suppose somebody says Smith is the murderer because the one who killed Jones was at the bank and Smith was at the bank. And it would be an equivocation if the one who killed Jones was at the money bank, all right? But it turns out that Smith was at the riverbank. I'm just going to draw those squiggle lines to indicate that we're talking about a river here. If somebody knowingly slipped in this word bank and that interchangeably, they would be committing equivocation, which basically means that you are using one word in two very different senses. So bank can mean riverbank. It can also mean money bank. And if you use these words in two different senses and try to get away with the two different senses, but try to pass it off as one word with one sense, you're committing the fallacy of equivocation. I think this is a more subtle example of the fallacy, but it's still a fallacy nonetheless. Here, somebody might say, only God can perform miracles, and the key term here is miracles. And they go on to say, these miracles can be seen in the smile of a child. So simply by seeing happy children, we know that God exists. The reason why this is an equivocation is because the term miracle, in the sense that is supposed to prove God's existence, is a sense where some event occurs that goes against the laws of nature, like Moses and the burning bush, or Jesus turning wine out of water, or walking on water, things like that. These things are events that go against the laws of nature. The smile of a child is certainly a lovely thing. It's certainly a beautiful thing, but it doesn't go against the laws of nature, so it's not using the term miracle in the relevant sense.